Hey everyone! One of the most common things I hear whenever I talk to organizations that use Mac OS is that Mac is so much more secure than Windows and that there's no need for endpoint protection software on Macs because of that. What I personally think is really interesting about that statement is that in fact exploit for Macs and exploiting Macs is just as simple as Windows. The huge difference is that Windows is still by far the most popular operating system for enterprise use. And what we have to remember is that cybercrime is a business. The target for cybercriminals is much bigger and thus more profitable if they focus more on exploiting the most common operating system, which is Windows. My point is that Macs, Windows, Linux doesn't really matter. You still need to make sure you put as much protection mechanisms in place. The bottom line of everything in cybersecurity is the amount of risk we're taking. We have to make sure that A, we're aware of the risk, and that B, we either reduce the risk by putting security controls in place or alternatively accept the risk. Obviously, we can't truly accept the risk if we don't fully understand it. I created a really quick demo to show how simple it is to exploit macOS running Ventura with no extra protection on top of that. I have two virtual machines running. On the left, you can see my macOS. I have the About screen open just so you can see the version. I'm running the default installation. The only thing I configured on that Mac is I just installed the developer tools because I am going to be using Python. And I also edited the etc host file just to make sure that the DNS resolution goes into my attacking machine and not to the intranet. But none of this would actually affect the probability of the exploit actually working or not. Obviously, if we're using Python, we need to have Python installed. On the right hand side, we have my attacking machine, Kali Linux machine. I ran the uname command just so you can see the kernel information and the version. I'm going to be setting up a reverse TCP interpreter listener on port 443, and I also have an Apache web server running on this machine listening for HTTP traffic on port 80. That's going to be the malicious website that the user logs into. We can see now that the listener started and waiting for the connection. For today's demo, my story here is that we have a user on the Mac trying to learn Python, and the user found a tutorial online. The tutorial gets the user to download a hello world.py Python script. In all honesty, this could be any sort of social engineering method, whether it's a phishing email, a drive-by download from a website. Didn't want to focus too much on that, just really wanted to focus on the example that if a user downloads and executes the files, it will just work. I'm just going to open up Safari and paste the URL. We land on the page instructing the user to download the script and run it from the terminal. This is the change I've made to the etc host file, so we can see that that learn Python domain is actually getting resolved to my Kali Linux machine. I'm going to click the link and download the file, and then I'm going to open up the terminal. We'll navigate to the user downloads folder just as the instructions are telling us to do, and I'll run the command python3 hello world.py. On the Mac, you see that the user gets the expected result, seeing the hello world message as well as a message saying congratulations for running your first Python application. From the user perspective, nothing bad happened and everything worked just as expected. On the attacking machine, we can see that we have an established connection and a interpreter session has opened. I can now quickly go into that session, drop in the shell, and now I'm executing commands on the victim's machine. First, I'm just going to upgrade my web shell by running this command using Python to spin up another instance of bash. Obviously, I need to run Python 3 here. That host doesn't have the regular Python version 2. Now I have a much more interactive and stable shell. I'll clear the screen and start doing basic discovery, running who am I. I can see the user Patrick B. I can see my host name. I can get the kernel information. I can check which groups this user is a part of. In this case, I can note that he's a part of the local admin group on this machine, which honestly 9 times out of 10 when seeing Macs in a corporate environment, the user will have local admin rights. Just want to quickly check my current working directory. And now I'm going to use curl to download some additional files from my attacking machine into the victim. I'll clear the screen again. I'll unzip those files, and as you can see, there were 4 files in that archive. We're going to use evil.py and the plist file to achieve persistence, the DNS exfil script to exfiltrate some data, and you can ignore the cleanup.sh script. It's just something I use to clean up all the artifacts and restore the Mac to its default state when I'm finished with the demo. I'll clear the screen again. Now, there's a lot of time-consuming steps involved in doing deeper enumeration of exploited systems. You really have to check everything that's running and might be further exploitable, check if there's any data on the machine that you want to extract. There's actually a few really awesome scripts that do a lot of that enumeration for you, and you kind of just have to sift through all that data. But just for the demo, I'll skip that part and go straight into the interesting things I wanted to show. In the user's documents folder, we have 2 folders. One called Tomcat, which we can assume has the binaries for the Tomcat web application. The other is called customer data. As part of the enumeration, I would look for files that might contain passwords or critical information. In this case, I'll just run a recursive grep command looking for the phrase password. We can see quite a lot of data is returned, but what I can see here is that it seems like we're having a clear text password for the user Patrick B as part of the Tomcat user config file. What I'm emulating here is a user that has clear text password in some sort of configuration file on his laptop. And in all honesty, you'd be amazed how many times users are using the same password for every single application, every single login that they have. So that's really what I'm trying to show here. We're able to get that password for the user by finding this configuration file. I'll clear the screen again. This time, if I go into the customer data folder, I can see a CSV file there called credit cards. And if I cat this file, we can see that in fact it has our customer's credit card information. Again, the user is storing critical information on their laptop. There's often the misconception that your laptop is super secure, and if you just keep data locally on your hard drive, it's going to be really inaccessible to attackers from the outside. Now it's time to exfiltrate this data out. I'll move the exfil script to this folder and clear the screen. I'll cat the script so you can see what it does. It's a very simple script that simply archives all the files that are in that current folder, then uses the xsd command to convert that archive into hex data, and we use the dig command in a for loop to send that data out to my domain using DNS. Once the attacker has all these DNS queries in his domain, he can correlate all that hex data and reverse engineer it with the xsd command, and he actually gets the data. As I kind of said, it's a very basic exfiltration technique that often goes completely undetected by modern security tools. When I run the script, we can actually see the DNS queries with the hex data in front of the domain name. Now that we have achieved our main goal, we can move on to achieving persistence. I'll move the evil.py script into the user's music folder to hide it in plain sight. Obviously, in reality, I would probably hide it a little bit better. I'll cat the evil.py file to show you what it looks like. It's a very simple reverse web shell, very similar to the one we had with the hello world.py script, just calling back to my attacking machine. In Macs, we use launch agents, which works very similar to the way startup folder works in Windows. We need a plist file which contains the configuration of a launch agent, and my configuration file points to that evil.py script every time the user is going to log into the machine. I'll move my configuration file into the launch agents library. I'll change into the launch agents directory and show its content. We can see the malicious file there. I can cat it so you can see it. As I mentioned, a very simple XML configuration file, just telling the system to run evil.py. I'll clear the screen again, and now all I have to do is to load that plist file into the launch agent control with the launchctl tool. Once it loads, you'll see that it straight away establishes another interpreter connection because it runs the evil.py script. At this stage, I'm just going to exit back out of all of my shells. If I can just type. Now moving back to the Mac, I'm going to close all the applications and reboot it. While it's rebooting, I'll set up the listener again in Kali, and I'll use the magic of video editing to make this go a little bit quicker. Now that the system is up, I can just log in as the user, and you'll see that we receive a connection straight away. And voila, I'm back in. And if I just run the whoami command, we can see that I'm that user again, Patrick B. I hope this shows the point that Macs also need endpoint protection software running, as this would have been blocked by an EDR tool straight away. If you like this video, I would really appreciate if you click the like button and subscribe. I'm working on more content. Also, please, if there's any feedback, good or bad, please leave a comment or reach out to me either on Twitter or LinkedIn. I hope you enjoyed the video, and thank you very much for watching.